So my name is Ben. I'm a software developer, and I help startups to deliver MVPs and large corporates to deliver at startup speed. And today I want to talk to you about a short project I did where I tried to build a Trump-Obama tweet classifier in 1 hour and talk about the approach I made, the challenges I hit, and the lessons I learned. I'm not going to dive deep into the machine learning details. It's mainly going to be discussing the implementation, the approach, but I'll give a few details for those of you who are interested. Who here has built classifiers themselves before? Okay, so about half the room. Cool. And I did it in JavaScript because I thought that would be fun. And also maybe there's an interesting application to loading machine learning models in people's browsers and having them personalize them to people's browsing habits, which I've seen some stuff in recently, which is really cool. So to start off, three-step approach I made for this was getting the data, building my model, choosing an appropriate approach, training the model, and then validating that the model works correctly. So how do we get data? Well, for any machine learning classifier, you need lots of data. I say lots with an asterisk because depending on your approach, you need more or less. So here I use a Bayesian classifier because I knew I didn't have a huge amount of data, but you need to find labeled training data for classification, and this can be very challenging. At the time, it was during the Trump-Hillary election, so I used Twitter as a source of labeled data. We see we've got textual data labeled with the author, with hashtags, many other things. And that's the first sort of lesson, to be creative with how we get our training data. The web sort of provides lots of different social networks, and a lot of those have APIs we can pull on to bring in data. I apologize for Trump's comments, by the way. So before I jumped into classification, I wanted to look at the data at temporal spread. We can thank someone on Wikipedia for this amazing graph. So in the middle, we see midday. At the top, we see the late hours in the morning. At the bottom, we see the early hours. And this is for Obama. So we see blue days are weekdays, red days are Sundays, and green days are Saturdays. And you can see sort of stays to a normal spread of the hours someone should be awake. Comparing that to Trump, it's quite a different pattern. So he takes the same sort of working hours, and then in January 2013, he changes his pattern completely. It's whole spread. But what correlates to that date? Well, that's when Congress declared Obama's second term in Congress. So maybe there's a correlation that at this point, Donald Trump started his political campaign. The reason I looked at the data in this way is, first of all, it's quite interesting. But second of all, I wanted to make sure we had enough data, and also the data was at the same timeline, so we can make accurate comparisons between the two. So now we've got enough data in numbers. That's 36,000 tweets for Donald Trump, which equates to 1 every 2 hours, and 15,000 for Obama, which is 1 every 8 hours. So we need to scrape that data. So I looked for a library that allows an easy way to scrape the Twitter API. And that's the second lesson I want to sort of convey, is when you want to use an API, rather than writing your own wrappers for the REST API, use a library that provides you an interface, because REST APIs change quite rapidly, so it's good to sort of have a library that obfuscates that from you. And second of all, you'll save time in writing your code, and your code will be more generic for when you want to add Reddit comments into the same model or lots of other things. So I used Tweet, which is a Python library. I know I mentioned we're doing this in JavaScript, but I did the data scraping in Python because Tweet is a really nice library. So the second step was to get a script to scrape the data. Now Twitter's quite nice. It lets us get around 9,000 tweets of a user, 3,000 tweets of a user, but you have to get them in 200 chunks. So I did a quick Google search to find someone who'd done the same thing and made a bit of editing. And that's the second lesson, third lesson I think on now. Look for other people's code examples. GitHub's a really nice feature where you can put the name of the library and then search for code snippets and see open source examples where people have used them. Obviously, I'm not saying copy people's work, but when you're trying to do your own projects, it's good to kick yourself off to see the best approaches of how people are doing things. So that's the original, and then editing that for Barack Obama and Donald Trump, we can get the data for them going out in a nice JSON format. Now you can see we have the text of the tweet, and also all the metadata about the location, the author, the date, and the time. But we've got issues with the data we're getting back. So the JSON array here is missing commas between the different objects, which will cause an issue when we move into JavaScript. So rather than have our code go through that in a parsing logic inside our code, I think it's best to use command line tools like awk and sed to clean up your data before you bring it into your code. So you're not being very specific to the APIs that you're using, and your model can be more generic, so you can test it out on different platforms. Once we've cleaned our data up, now we want to build our model. So we had to think about what model we want to use, how we're going to train it, and then how we're going to validate it later on. So time for that cutting-edge machine learning. I use Bayesian statistics, which goes back to 1763, although the splitting down into independence is obviously a more recent development. I also love that song. And what helps us use a Bayesian approach is this idea of conditional independence. So we can assume independence between the different events that we're classifying, and that allows us to break down the probability distribution in a much more computable problem. And as Russell and Norvig say, the authors of Artificial Intelligence: Modern Approach, which is a really good textbook on machine learning and AI, this is one of the most important developments in the recent history of AI, this splitting down of conditional independence to break down probability distributions. I guess it's more in the recent area of probabilistic AI than all AI, but it's really interesting to see. So now in building our model, so now we move to JavaScript. So I use the Bayes library to train my model, or to build my model. It's an NPM library that can be easily installed and has a really nice interface for training. So we simply do a Bayes require after NPM installing the library, construct our classifier, and then we can classify. We simple classify.learn what we want to classify, and in this example, if it was sentiment analysis positive, and this example negative. For our tweet example, we want to use it a bit differently, so we put in our tweet text, the author is Donald Trump, or Obama's presidential handle. What I've glossed over here is what feature set are we using. So with textual data, there's many things we could use. We could use word length, term frequency, or term frequency inverse to the document frequency in the corpus, hashtags in the Twitter example, and many more. What the Bayes library uses by default is tokenization and then builds a frequency table, and it's a term frequency that it uses. So the tokenization code is very easy to understand. It's a simple regex to split out anything that's not text, so splitting out punctuation, and then splitting out double spaces, and it splits up into the individual words. And you can override the default tokenizer as you want to. Then we build a frequency table matching each term to how frequently it's used. More advanced approaches we could use is term frequency inverse document frequency, where we divide how often the term is used with how often it's used in the corpus. Stemming, where we remove the ends for words, so stemming would become stem. Stop word removal, like and, the, of, a, so we don't classify things that are less meaningful. Lemmatization, which is sort of a more advanced version of stemming, where we use part of speech analysis to get the different versions of words, so we can be a bit more advanced in how we do that. And GLOVE, which is a global vectors for word representation, is a trained model on a large corpus of documents, which allows more advanced term feature extraction. Under the hood, to jump to some of the details, I know this is a horrible slide that's covering things, but for those of you who are interested and have a knowledge of Bayesian statistics, we're using a multinomial model, not a binomial model, as multinomial models have been shown to be uniformly better. We're using a bag of words assumption, so we're taking into account the number of times a word is used inside each document, but we're ignoring the order between the words, with words being the events and collection of words or documents, and a Laplacian prior, so starting every probability at 1 or every term frequency at 1, which allows the maths to be a bit cleaner. So when we start using the classifier on our example, again, we import Bayes, we import the tweets of Trump and the tweets of Obama, we build an object here with the president's name and the tweets of that president, and then we simply construct the classifier and iterate through each president and then every tweet of that president, using the classifier.learn with that text and the president's name. And to test that on some random data, we could classify let's build a war, which comes out as Trump, or climate change is important, which comes out as Obama. That's not exactly a scientific approach, or probably a politically correct approach. So the next step is validation. So a scientific approach to how we validate our model. Again, I was doing this in an hour, so I was trying to move through as quickly as possible. The classic validation approach, which I took, is to get our historic data and split it into our training data and our test data. So taking a subset of the training data to test our model on in the validation. Not to call our classifier a black box, because obviously we want to be able to interpret it. We put our training data into the classifier, which is represented as a black box on the right, and then the test data is validated against it after we've trained our model. In the library that I was using, it looks a bit like this. So we have a classifier.learn for every X element of the training data set, putting it into the classifier, and then we validate the test data, doing classifier.classify on every Y element of the test set, and seeing if the output matches what we expect. But how do we choose that split between the training data and the test data? Well, there's two classic approaches. The holdout approach, which is a 70%, 30%, although the numbers vary there, split of training and test data, that can bring in a lot of bias in how we validate. So I chose the cross-validation approach, which is a bit more advanced. So the cross-validation approach I chose was leave P out validation. So we choose two elements to leave out, we choose P elements to leave out, where P equals 2 in this example. We have them as test data, and we use the rest as training data. And then we have to select every way we could select that P number out of the set. So for 2 and 4, that's 6 combinations of test and training data. The interesting point I realized here is I had to run the model in the time I had left in this hour. So this is the classic Pascal's triangle. And the example we had, I can use a laser pointer, so we have four data elements. I wanted to select 2, and it's a 0 index from the top and from the side. So that gives us 6 models we'd have to test. So every time we make a split, we have to trash the last model, build a new model, and then test our data. There could be more advanced approaches where we could remove the things we've already tested on, but I didn't have time to implement that. So that'd be 6 models we'd have to build and trash. Let's say we scaled up to have 16 data elements and we wanted to select 2. That'd be 120 models we'd have to select and trash. So I wouldn't have time if we were having 9,000 data points to build and trash that many models. So I chose P equals 1, which has a nice characteristic that we'd have 9,000 models to build and trash if we have 9,000 data elements. And what we're going to measure as we test and train on each of those selections from the data elements, we want to measure the fit, more the fit in the real world than the fit to our training data. So the goal of cross-validation is to have a measure of the model's performance that's independent of our test data, of our training data. So what we want to record is the true positives, the true negatives, the false positives, the false negatives, the rates of how accurate our model is. So the code for doing this, again, we have the same import of Bayes, the same import of Trump and Obama, constructing the data in a nice object, and now we initialize some counters for true positives, true negatives, false positives, false negatives. I added a timer just so I could know how long my model was taking. And then we iterate over each element of the data, each possible test index. Because our test index in a minute is we're selecting one element, we're going to iterate through, construct our classifier, construct a test data array, and then again iterate over the precedence of the data, the tweets of that precedence, and increment our counter each time. And when our counter is equal to the test index, that's when we select that element to use in our test data. Test data here is an array, although it's only one element in this time. I was messing around with some other approaches and trying to keep the code extensible. So we iterate through, we ignore the one that's the test index in this instance, and then we iterate through the test data. We classify that test data using the model we've just constructed, and if we're correct, for Obama, that's true positive, otherwise true negative, and for Trump, it's false positive and false negative. And then we iterate through again. So we increment the test index, we trash the old model, and we validate again. And the result of this commands confusion matrix here. So 3,195 tweets were Obama when they should have been Obama, and 3,123 were Trump when they should have been Trump. With 82 errors of Trump being classified as Obama, and 27 errors of, 82 errors of Obama being classified as Trump, and 27 of Trump being classified as Obama. Putting that as accuracy, that's 98% accuracy. So going over what we went over, data. So we want to get the data we need, being creative about how we can get training data in situations where we don't have a nice data set. We have to choose which model to use existing libraries to build it, and then validate our model. Validate our model using cross-validation or a holdout approach to validate that our model is accurate in the real world and not just on the training data we had. The conclusion really is you can use machine learning techniques without having to dive into the maths. We skimmed over some of the maths elements there. Obviously in production, you want to understand the maths to understand why your model is doing what it's doing, especially with the GDPR things we were talking about a second ago. And there's some great libraries to simplify the application of machine learning. And you don't have to do it in Python or R. You can do it in JavaScript, and there's a growing number of libraries there. And you have access to more labeled historic data than you think. You can be creative about where we get our labeled data from, be it Twitter, Wikipedia, and Cable has some really nice data sets to download and play with straight away. I've been Ben. I'm a developer at Theodo. We help startups deliver MVPs as quickly as possible and larger corporate clients to deliver at startup speed. If anyone wants to drop me an email with any questions, although I'm going to hang around afterwards, and any questions we can fit in now, would be great. Sorry? Yes. I was working on a project.
So I'm curious what some of the things got misclassified. Do you have any examples of times where Obama was mistaken?
Yeah, someone has been saying comment on the blog post I made at the same time. I've not gone through them all. We can have a quick look. And if you go to the blog post here, you can see in the comments and look through the data yourself. So I made a paste bin of all the misclassified data. The formatting might be great. So these are the misclassified tweets. That's way too zoomed in. So America Dream is back. That got classified as Trump, and it's actually Obama. Because obviously the use of America and Dream is often Trump's tweets. As your president comes up, and a lot of Trump's tweets as well. I won't run through all the tweets now, but feel free to look for yourself, and it'd be interesting to see what patterns we can come out of that.
So it's very interesting you to do it in JavaScript. I've never really seen that before. Is that so that you can build it into static websites and have it literally working in people's browsers?
Yeah, so the idea I originally had was to also, in that 1 hour, build a static website where people could put in their own tweets and see who they came out as, but then I realized 1 hour is quite a short amount of time. So I'm hoping to do that soon. But also, there's some, I can't remember the name, there's something in the Hacker News recently where someone's, more work is being done in having models sent to people's browsers and staying in there and personalizing themselves to the person's browsing history. So Netflix, for example, could have a machine learning trained model just stored as a JSON inside of someone's web page that personalizes itself to them without that model being stored back in the server, which could add some latency or maybe some data protection issues. But no, I've not played around with myself. Yeah.
Okay. We see high accuracy here,
Mm-hmm.
which is like, thank you for the talk. It's like great to see that it can be done in JavaScript in 1 hour. But if you were to improve it in some fashion, what would your steps be? If you were to work on this further and say, we want to predict, distinguish between more people as more classes and so on, what else could you do?
I think the supporters of different parties could be an interesting one. So there's a way that the Twitter users who specify which party they support, or a way we can infer that. It'd be interesting to see if you could predict the tweet of a Democrat or Republican, or a Conservative and a Labour supporter. Other than that, it'd be interesting to try some different approaches, maybe a k-nearest neighbour approach, or maybe a neural network, though I don't think I have enough data. And also, it's been several months since I did this, so hopefully there's some more data that I could train it on, and maybe see if I train it on more recent data, if there's a change in the accuracy. Yeah, any ideas yourself?
So the approach he has for natural language processing before you actually apply the Bayesian logic, like for classification. I'm curious about the library you mentioned with pre-trained model.
Yeah, the Glove library.
Yeah.
I've not had much chance to play around with it, but yeah, there is. NLP is obviously a massive area, and there's loads of libraries that we could use to extract better features from the set. So the time frequency is pretty basic, because it's in the minutes. There's no inverse to the document frequency, so some terms like president are probably coming up loads. No stemming is done, no stop word removal, so and, the, of, your, which had quite an impact. And there's no lemmatization for more advanced stemming. And yeah, the next thing I would like to do, which I'd forgotten to mention, is to apply Glove in how we look at the word analysis. Because that's obviously, I might be finished, that's obviously trained on a much wider corpus trained on a wider corpus for the word analysis.
Ours?
So any more questions? So do you guys want to break or do you want to move on to the next talk? I'll let you choose. Move on? Okay? Yeah, okay then. So where is... Thank you, man. Thank you, man.